Hello guys, welcome to my YouTube channel. So today we will be solving educational code forces round 157 problem B, points and minimum distance. Okay, pause the video, read the question, then I'll explain. Cool. So in the question we are given that we will be given an array of length 2n. Now we have to split this array or into n pairs, or like this 2n integers into n pairs, such that one of them will become x and another will become y coordinate. Okay, so basically what the question says that we'll given two n integers, we have to make n pairs such that one will be x coordinate and other will be y coordinate. So let's say we have like x1 y1 x2 y2 till xn yn. Okay, now what we need to do is, let's say if we need to traverse each and every point. We can start from any point and we can end at any point, but we have to go and visit all the points at least once. So let's say if I started with x1 y1, then I can, let's say, here are my points, right? So I can go in this way, this way, or let's say I wanted to go something like this, then here and then here. So whatever the scenario, or like whatever the path we want to follow, we can follow, but the only condition is that we have to return the minimum distance. And the distance is calculated as x1 minus x2 plus y1 minus y2. That means if we are going from point x1 to point x2, or better to write, if we are moving from x1 comma y1 to x2 comma y2, then in that scenario the distance will be x1 minus x2 mod, or the absolute value, plus y1 minus y2 mod. Okay, so let's say we started with the first point, then finally we traversed all the points and reached till end point, right? This was the first point and this was the nth point. Order can be anything, but once traversed everything, there will be distance, right? And that can be calculated at whatever, according to this formula, that from moving from point 1 to point 2, we will have that much distance or cost, we can say. Now we have to return that minimum cost, what we can, in which we can travel all the points. Okay, or the path length, we can also say. So like the minimum path length we will require to travel all the points, and also the order in which we will travel the points. Okay, I hope the question would be clear. Now let's see. So if it's a grid, right? If it's grid something like this, or better simply, let's say some points will be here. We are not sure, right, where the points are. I think they are positive, all positive. Yeah, sorry, it won't go this side. So here something like this. So like, before starting with 2D grid, let's start with something like 1D grid. So let's I am saying that you have some points on this number line. Okay, some points on the number line, and you can start from any point and end at any point. Okay, but again the condition is same, that minimum path length, or the cost or the path length should be minimum. Okay, minimum cost or minimum path length. Okay, and also give me the order. So so let's say you started from here, you went here, then come back here, then went here. So what we realize, that we are kind of repeating some distances, right? So we can simply visualize for 1D that either we start from this one, then go to 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 this one, or we start from this position and come to this one and come to this one and come to again this one and finally this one. So in this scenario this will be our minimum distance, right? But if we'll follow otherwise, I mean, if we go or follow any random order, like we go to this point and then come back again to visit another point, so we'll be repeating distances, and in that scenario we won't have our optimal minimum path length or minimum cost. Okay, so from here what we realize, that if we have our points on a straight line, then we can either go in this ascending order, or we can come in descending order. That will be our best path. Now if we look at the question carefully, what actually distance was, if we are moving from point 1 to point 2, then this was the distance, right? And we know that if we are not considering this one, or let's say for there are n zeros and this was everything zero, so we will left with this one, right? So in that case we know that it's always better to go in ascending order, right? Similarly, for y as well, we can say the same thing, right? For y as well, we can say the same thing. So, and now we know that we know that like if it's a 2D graph, right? If it's a 2D graph, okay, we know that if this is the sorry, the minimum point can be zero, right? So if starting point is this one, and let's say ending point or the highest point is this one, right? And there were so many points in between. We know that if we just want to consider x, so what will be the maximum value or the maximum path length we can have for x? What is the maximum path length we can have for x? So that what we can do is, like out of all the points, in all the points, if we want minimum path length, sorry, not maximum, if we want minimum path length, then we will we, visit them in increasing fashion, right? And that will give us the minimum distance. Similarly for the y, we have to follow the same. If we'll start from the lowest point and we'll go to the highest point, that will give the minimum points. But there might be, uh, so like now, how we can make sure that we go in this fashion. So what we can say, so we have two n integers, right? So if we'll short them, then the first n sorted or increasing, I would say, like the entire is increasing, so we can take first of them as x coordinates, and second n or second half as y coordinates. Why so? Because we know that if we'll take this one, so if this is the starting point, this is the ending point, then the total distance will have to cover it. We can simply subtract this one minus this one, right? Remaining points, like even if we'll take the absolute distance between them, the end result will be the same, that we can simply subtract uh, this point from this point, right? Similarly, if we'll take this y, then also we can simply write that, like we'll go something in which or how we'll go. So first of all, we'll take this one x1, and from here we'll take y1. Okay, from this next we'll take x2, and then from here we'll take y2. So in this scenario, what we'll found out that this x1 goes on increasing, similarly this y1 goes on increasing, and we know that this is the best possible way for minimum path. Else, if we kind of repeat any point, then we will have our cost increase or the path length increase, because we have already seen that, right? So from here, what we realize that we just have to sort this and divide them into two halves. The first half can be considered as the x coordinates, and the second half can be considered as the y coordinate. So we know that now the total path length can be simply either subtract this middle one from this one, and this last one from n plus 1. Okay, and we can simply print, we want to print, we can print this first x then first y. Similarly, we can iterate over this n length, and we can print both x and y, and that will be our minimum answer. So that's what I have done. First of all, taken the input, sorted them, then we know that yeah, we also need to calculate this sum, right? Though I was solving during the contest, so I have done this way, but you can always you know simply subtract this n minus 1th, sorry, nth minus 0th plus last minus n plus 1th. So that way, but here I have calculated the absolute difference in the manner we can go point to point. And finally, I am just printing the points, like the x, the first character is, let's say, or the first point is x, then I plus 1th will be y. So I am printing the x and y because we have to print in the same fashion, right? So I hope this would be clear to you, but if you guys have any doubt, let me know into the comment section. Thank you guys. See you in the next video.